All right. Thank you, Winnie, and good evening, everyone. Thank you for joining us, and welcome to tonight's masterclass, SOCA masterclass. This segment or series of agribusiness advisory masterclasses that we have been having or airing over the last 2 months, tackling various topics and issues that are relevant to agribusiness. My name is Ricky Aguda. I'll be standing in for Nekesa Wafula, who is our host moderator, if I may use that term. So I'll be standing in for her due to a late illness. So our apologies that we have had to make some last minute switches, but we trust that we're going to have a very rich and informative session with you. And of course, with our presenter for this evening, who I shall introduce in a minute. So before we have the introduction, I want to briefly just mention for those of us who may not be familiar with SOCA and give us a bit of a background. So SOCA is an acronym that stands for the Society of Crop Agribusiness Advisors of Kenya. It is a business member organization that brings together professionals in agribusiness who provide what you'd call extension in the private sector, and of course also in other sectors in the development space and also in the public sector. So our members are advisors who work with within the agricultural space and provide information, input, technical support, covering a wide range of agricultural issues, all the way from seed and plant material to production, to nutrition and irrigation management and crop protection. Of course, the broader topics around production or agronomy, as we call it, and of course, then also moving to post-harvest handling, issues around market access and standards, compliance to standards. So it's a platform, it's a networking space for professionals that also then allows us to engage in aspects of policy advocacy and of course provision of technical support by way of support to projects, support to partnerships and platforms where the inputs and opinions of advisors are welcomed and are critical just to help us all develop the agricultural space. So we welcome any of us who are following tonight's meeting who actually qualify to be a member of SOCA, because we're open for membership. To engage with us, you can get all our details on our website, which is www.socaa.or.ke. So coming to our segment this evening and or this afternoon, depending on where you are, we are privileged to have with us Dr. Michael Groom, PhD, who is an accomplished agronomist and co-founder of Scarab Solutions, where he currently serves as Director of R&D. Michael, who I have the privilege of knowing personally, has over 17 years of experience as a scientist with the Centers of the Consultative Group for International Agricultural Research, or CGIAR. Some of us may be familiar with that acronym. Michael brings a wealth of knowledge and expertise to his role at Scarab. His contributions to the development of the company's core analytical software have been instrumental in the success of Scarab scouting systems, which are among the pioneer in terms of using tech products and tech tools to do what you'd call precision scouting. In his current position, he oversees a team of software developers in Cali, Colombia, and coordinates hardware development with subcontractors in the UK. Tonight, Dr. Mikel will be taking us on a presentation and a talk on how spatial data is transforming IPM, integrated pest management. And we are looking forward to the insights that he will provide into how new tools have enabled the collection of spatial data and how this data is fundamentally changing some key paradigms of integrated pest management. So we are really looking forward for anyone who is an enthusiast of integrated pest management and how the principles of integrated pest management can help us to have a sustainable crop protection systems. This is really the presentation and the session for you. So of course we are looking forward to gaining a deeper understanding of the impact of spatial data on IPM strategies and the potential benefits of integrating this data into decision-making processes. We're also going to explore through his presentation new tools in spatial data collection and analysis, and of course offer or look at practical examples of how these tools have been successfully implemented in IPM programs. So without further ado, I want to welcome Dr. Mikel Groom to take us through his presentation. I urge us, for those SOCAM members who are, of course, participating directly on the Zoom platform, you can always use the Q&A tab to drop your questions as we go along. And then, of course, at the end of Dr. Mikel's presentation, we'll come back to those questions. And for our audience on Facebook, please use the comments box to let us know whether you have any questions or comments. And then, of course, we will also incorporate them in the Q&A session after this presentation. So without wasting any more time, karibu sana, Dr. Groom. Welcome back to Kenya, and it's a pleasure to have you with us. Mikel?
Thank you very much, Ricky, for that welcome. Those of you, well, some of you will know that Scarab was originally founded in Kenya in 2005. It was at that time the world's first and only GPS-based scouting system. So really pioneers in spatial data in IPM control. Scarab later expanded beyond Kenya to Ecuador and Colombia, and currently to the UK. Most of and other countries in East Africa, Tanzania, Uganda, Ethiopia, mostly in the flower business, where I think the returns to the work have been the greatest in terms of the investment that flower farms are willing to put into producing spatial data, scouting particularly, which is a large part of what this is a large part of how spatial data is created today. I still think it's one of the best methods to create spatial data. I will talk about first how spatial data transforms some of the actions that people have in IPM, some of the goals that they have, and I'll take you through an example, and then move on to talk about some of the new tools that we have that are available for other crops outside the flower growing industry, and how those can be used, and how they're also available to, we've specifically targeted some features to consultants. And then finally, I'll round off with talking about a new technology that we've developed and are about to launch, and it'll actually be the first time that we're presenting it in a public forum. So we look forward to doing that.
Mikhail, thank you. Just a small interruption.
Yes.
I apologize for my background noise. Perhaps for those who may be laymen, and are following us, especially on Facebook, maybe you would just also just say a bit about spatial data and just give it a bit of a context before you move into the presentation, if you don't mind. Thank you.
Right. Spatial data is data that shows the distribution through fields of pests and diseases. This can be, spatial data can come from a number of different sources. You can have, well, these days, you can have satellite imagery, you can have drone imagery. You can have a number of sensors in your field, but I still think that the most common and the most reliable source of spatial data, of spatial pest and disease data, is simply scouting. And we'll come into that, talk a bit more about that. I'll also be showing some maps in presentation. So the old approach to pest and disease management was that you don't need to, it's called the economic threshold theory, which basically says that you don't need to intervene until the potential damage will be greater than the cost of intervening. Now that sounds very sensible and has been the dominating decision-making theory in pest and disease management for many, many years. And it's largely based on the fact that you often didn't have any spatial information. You didn't have any information about where in your field you had a problem, and you didn't have very many solutions that could address fields only in a part of your field, address issues only in a part of your field. So based on the idea that you spray a whole field or you don't spray a field, you end up with the conclusion that you're really not going to spray your field unless the damage that you're likely to have is going to be more than the cost of spraying. That makes sense. Now, a number of, and that served people well for a long time. Now, spatial data, when you start knowing that your problem is only on this tree or only in this corner of the field, you can start making other decisions. You also have, when you start moving into IPM, integrated pest management, you have a number of other solutions that aren't necessarily an all or nothing. If you spray, whether you have a few pests or you have many pests, you will spray the same doses, you will spray the same area usually. So now, if you happen to know that you only have the problem in a small area of your field, and you know that, for example, a predator release may depend on how much you have in the field, your decision-making process changes, and you have the ability to step in earlier, keep your problem small, and thereby save a lot of crop and save a lot of costs in terms of intervening. So I'll show, I'll go through a simple example from the rose industry that we've seen. And it's the rose industry, basically, when we started back in 2005, it was very much dominated by the use of pesticides and I'll talk specifically about the control of spider mites. So the question, so then slowly they started moving into using natural enemies or biological control agents, the predatory mites, to control spider mites. Initially, this met with very limited success, really. Part of the reason was that a lot of the chemicals used were very strong. They killed the predators as well as the spider mites. And it was very difficult to establish predatory mite populations in the field. Slowly, probably the first thing that happened was that a product called Silhouette Gold, which is basically it's a soap. It's slightly more refined than that, but it helped. It could control spider mites without having much of a residual property. And therefore, it was easy to release predatory mites immediately after having used it, which changed the nature of spider mite control. But there were other aspects that also took a long time. So let me start just by asking, how many spider mites should you tolerate in your crop? And the answer to that question has changed over the years. For many people, for a very long time, there was this idea that you create a balance between your predatory mites and your spider mites, and your predatory mite population would thrive among your spider mites, and it would control the spider mites and keep them below a level that would cause serious damage. I think today, most of the most successful users of predatory mites will argue that you should target zero. You should have no spider mites in your field. That doesn't mean that you won't have any, but it means that should be your target. That should be what you're aiming for. And I'll go over in a lot of details why that is the case. Yeah. So the industry has, as I gave history, has worked towards a zero tolerance strategy that has resulted in Kenya really having a very successful strategy. I'll go over some more details here. One of the reasons that you need to target zero is based on the fact that predatory mites don't do very well in the rose crop, at least. They eat, but they don't lay very many eggs. If you see here, we're talking about eggs per mobile spider mites, or the species, let me just go back. Tetranicus, which is the common spider mite in the two-spotted spider mite, which is found in roses, both in Kenya and Ecuador, and I'll be looking closer at the situation in Ecuador and comparing it with Kenya. Sorry, I've got the name Kenya spelled in Spanish here. I have translated some of the slides here from Spanish, and I didn't get that translated. I hope I don't have more of those mistakes. But basically, the thing that you've got to think about is that the spider mite that you don't kill today will be 2 spider mites in 3 to 4 days. So let's say, based on some of the information from Coppet, for example, a predator can eat 20 spider mites adults in 4 days. If you have, as an example, 10,000 spider mites and you release 50 predators, they'll be able to eat 1,000 of those spider mites. In 3 to 4 days' time, the other 9,000 spider mites will now be 18,000 spider mites, and you will need to release 900 predators where you could have got away with releasing 500. So that's the basic philosophy. Predatory mites are very, very different from chemicals. The more spider mites you have, the more predatory mites you need to release. And it's Our experience in the rose industry is that you're talking about 1 to 10 if you want to be successful. The number varies slightly according to conditions and a lot of different variables, but it's about 1 to 10. So getting to the spatial part. So the difference there between predatory mites now and your chemical is that with your chemical, you'll spray the same amount, whether you have few spider mites or many spider mites. With your predatory mites, you will release many, many more predatory mites if you have many more spider mites. So we need to get them down. Now we're getting to the spatial part. What we have here is a map of a greenhouse. The red is spider mites. So the redder it is, the more spider mites you have. And you'll see over here, you have lots and lots of spider mites. And here you have some areas that don't have any. This is a very typical scenario for spider mites. You may even have them more clustered. They tend to figure in hotspots. Now we've taken all the plants in this greenhouse here, and we've put them in a line, in one long line. And we've put on the right-hand side, we've put all the plants that have the most spider mites. And then on the left, we have those with the least spider mites. Now, if you release predatory mites, enough predatory mites to eat all those to eat all those spider mites, you will release at about the level of the dotted line here. But that's the numbers. If you release them evenly, the ones in this section here that you release on all the areas where there aren't very many spider mites will eat the few spider mites that are there, if they manage to find any, and then they'll die of hunger. And yet you have all these predatory mites here, all these spider mites here, where you don't have enough predatory mites. These predatory mites will, spider mites, these spider mites will thrive. They will outnumber the predatory mites, and they'll spread to the rest of your field. So this is a way of illustrating that where you release your predatory mites is incredibly important. Now, obviously, this varies a lot from one pest to another, one predatory species to another, but generally predatory mites don't move very far. So this is where you really need to have maps. You really need to know where your predators are. Another way of doing spatial information is simply to put flags in your field. The flags don't show the same level of detail, but at least that's another way of getting spatial information on your field. So now that I've tried to show how spatial information is important, I'll try and show 2 examples. Now we've got a map here of a greenhouse that had a few spider mites. I'm not quite sure how clear. I hope the color is clear enough on these, but the levels of spider mites in this field are fairly low. This is the field on the left. This is where this shows spider mites. On the right, we have a map that shows predatory mites, and it shows gray dots in the field where you have enough predatory mites and don't need to release anymore because they're already coping with the spider mites that are there. And the purple area is where you still need to release more. So on this farm, they used this example. They did this, and you can see on the next map, the next date, a week later, they were doing better. and they kept releasing, and they kept getting better and better results until they had very, very few spider mites left. And notice one thing: the work that you have to do every week decreases when you release enough spider mites. The cost of releasing predatory mites, the cost of releasing predatory mites goes down each week when you release enough. If you don't release enough, the cost will go up every single week. This is the importance of getting enough in and distributing them well. So there's an overall strategy here. I'll just quickly summarize it. It's you need to reduce your spider mites before you even start to release predatory mites. You cannot afford to release predatory mites until you come down to a reasonably low level. In roses, I would argue that you need about 0.5 spider mites per leaflet on average on your plant before you should start predatory control with predatory mites. Below 1, you can probably succeed. In other crops, the numbers will be different. You need to get your spider mites as low as possible, because that will give you the lowest costs in the long run. And you need to be very consistent. You need to make sure that you're releasing those small amounts of predators every single week. If you have good scouting data, you will be able to target those well. And if you miss some spider mites one week, you will be there the next week, and you'll be able to keep them under control. So, we're talking about the difference between having 10 million spider mites in your field or having maybe 100 in your field, getting down as close as you can to 0. This also opens up new strategies. It means that you can go in and maybe you can spray your thrips, because your thrips will be a problem. And you may not have biological control for thrips. So a good zero tolerance strategy opens up other possibilities, not only reduces your cost of spider mite control, but opens up other possibilities for other actions that would otherwise harm your biological control. Yeah. So I want to talk about how this has worked in Kenya, because it's really worked very well. If you go back 10 years ago, Ecuador and Kenya had very, very similar levels of spider mites in the flower industry. They had an average of 2 spider mites per leaflet. It was costing, if you go back even further, spider mite control was often 60% of the budget of many farms, of their pest and disease control budget. And so it wasn't just the number of spider mites, it was also the cost of controlling them was incredibly high. But Kenya, of course, worked very early on biological control. Biological control has not had the same success, and the same effort hasn't been put into biological control in countries like Ecuador and Colombia. And here is the result. About 8 years ago, Kenya started reducing the number of spider mites. They had had biological control for a number of years, but people were fixed on this idea of trying to get a balance between your predatory mites and spider mites. Slowly, a lot of growers started realizing that they needed to target much, much lower levels of spider mites. And in fact, in 2017 was the first time that I heard a grower saying the target is 0. The target is 0 spider mites. This worked. Today, Ecuador has 5 times as many spider mites, more than 5 times as many spider mites per leaflet as Kenya has. Ecuador continues to use chemicals, continues to try and control spider mites with chemicals. And Kenya today has a very successful growing strategy or control strategy using predatory mites. So this is just now an example of what you can do with spatial data. I want to be clear, spatial data is not useful for all pests and diseases. You've got different types of pests and diseases. Some pests and diseases will come flying in with the wind over your field and take over your whole field in very short time. And it'll be everywhere. And you don't necessarily need to know that, well, you do need to know that it's everywhere, but you won't have any advantage in knowing that it's in a certain corner or not. But there are other things. I mean, even when you get, let's say, whitefly blowing in with the wind, very often you'll get single whiteflies coming in and they won't be doing very much harm. But then suddenly you get a point where a whitefly manages to establish. You start seeing immature whiteflies, the population starts growing. But usually that won't happen all over your field. Very often that'll happen in a corner of the field or a few spots, and it'll start growing from there. And if you can get in early enough, stop that growth, you can also stop the damage and the outsized costs that you may incur in controlling that in the future. So I'll move over to, for many years we worked in the rose industry, where we have our scouting system that has been used there. And recently we've released a new tool called spot.ag. Any of you can go to the website. You have the possibility of using it for 30 days and looking at what it can do, what it can't do. It's a scouting system for open field crops. So just to look at an example here, I'm just going to show you an example which has a real farm, but it's a real avocado farm. The data are not real. The data, well, some of them are mixed with simulated data, just so that I can show you examples. But the idea is real. So let me just go back a few weeks. So here we have, you can see we have 4 scouts here. We have a scouting template here. We have the different pests and diseases. As I move my mouse over the data, over the menu here, you'll see different pests and diseases and their distribution pattern in the field. So just to explain, the white spots are the places where the scouts have been and recorded that they've been. They have not necessarily seen any pests and diseases, but they've recorded that they've been there. They may have recorded other pests and diseases than the ones you're seeing, but it's important when scouting also to have negative observations. That is, observations of where you don't have something. So here, let's have a look at fruit fly. We've got fruit fly in these fields. We've got fruit fly in this field. We've got fruit flies over here. But we've got some fields here and over here that we don't have any fruit flies in. We've also got some fields here, here, and here. And this is all important information if you're trying to tackle a problem. It means you can, and this may have started even earlier. They may have even been able to intervene even earlier if they had this information and limited maybe the growth beyond that. The way this data is collected is through an app The app can be downloaded from the Android Play Store. So basically, I just want to tackle some common questions. The app is for recording observations that you make. So it's still a human being recording these these observations. It's not a camera recognizing things, though the app has a gallery. Let me just, I'll stick to the result here first. We'll go, so we have these number of points here. We can also, on this same page, look at who actually collected this data. So for example, here we have where Thomas was and where he scouted during that week. So this is interesting, because what we can see is that we may have feared, for example, that the difference between a field where you see fruit fly and one where you don't is that one scout may be good at catching fruit flies and another not. But here we see that Thomas actually does observe fruit flies when they are in the field he's in, as we see here and here. But that he's simply been in some fields that don't have fruit fly. So these scout tracks are important for to detect biases and look at what this is all human data, and we need to know the humans involved in collecting it. So yeah, we have, let's see, we can also see the names of the different fields if we want. And we can go back a week and look at what did they do, what did they find the previous week. And see, they found a lot more fruit flies the previous week. They may actually have made an effort to control them. So in terms of results, we also have data tables where you can see results, both incidence, severity for count data, severity for percentage data. You also have charts with trends. So you can see that in, let's take a look at 3 random fields in this. I know I want to look at avocado and not avocado traps. There's also traps template. So we have your different levels of things, and let's look at how fruit fly has developed over time in this field. So it looks like there was a time when they were controlling fruit fly quite well, and then suddenly it took off here around the middle of April. And they've been able to bring it down in this field, but in other fields it seems to have stayed up. So this is now what has been the other thing that we see here is this is a general overall fruit fly map, but what we look at is it's broken down into the fruit flies and the damage. And what we see is that what people are actually recording is the fruit fly damage. They're not seeing very many fruit flies. So this is another level of detail that the app will allow you to keep an eye on. So basically, so the 3 types of outputs are maps, data, tables, and trends in terms of charts. So there are several other things. Let me just quickly take and create another farm. Just one more thing. there's a gallery. The gallery here of all the pests and diseases. Now, this gallery is also found on the phone. So the scouts themselves can look at the different pests and diseases, study them. There are more details. You want to go in and you want to look at weevils. You want to look at what weevils look like, what larvae look like, how you identify them, and how you identify the damage. There are pictures and there are texts explaining all these details for each and every pest and disease. Yeah. Now, that is generally what the app can do. I'll just quickly try and show what it might, how you can get started. When you log in for the first time, I'll actually log out, so we'll see from the outside. You can log in either using Google Maps or log in a new user, register a new user. You then search for your location. I am going to search for a location near myself. So this is where I'm going to create a farm here. So you drag this marker to the farm. Then you click the next button, you name the farm. I'm going to name it Starbridge 5. And I'm going to say my crop is avocado. Let's see, we have a, oops, where did I get that? Yeah. And I'm going to register the farm. So there are terms and conditions that you have to say that you've read. And like most other people, I will lie and I will jump straight into this. And so now I have registered a farm. Once you've registered a farm, you will want to register a scouting device. So you go down here where you have your devices and you register a new device. This is sorry, there's an error occurring here. But basically what you do is you get a QR code, you get the app from the App Store, and then you scan this QR code. And once you've scanned that QR code, you are then able to use that device. That device will be linked. The purpose of that is that that scouting smartphone will be linked to your farm. And you can go ahead and start scouting. You can add new users here. You want more users, and these are, in this case, when I'm talking about users, I'm talking about people on the farm. You can, for example, if I want to add another co-worker at Scarab, I can add them here and register them. They will get an invitation, a link, and will then be able to enter the application and see all the data. When you've done that, you can start scouting. Once you've got the app, I had originally hoped to display how the app works, but I won't be doing that. I had some trouble connecting the app correctly to the presentation, but basically it should be fairly straightforward. You log in, you select your pests and diseases, you select your crop strata, you know, whether you want to record data in your fruit, whether you want to record data in your branches, etc. You then record the pests and diseases that you see. Records are done in different ways. Some of them are percentages, some of them are numbers, some of them are scores. Each is explained in the app. The app already has a template for your pests and diseases. And you can go ahead and scout. The scouts register themselves on the app, and you'll be able to see the scouts listed here. We can go back to our existing farm to see that. So here we have a number of users. Sorry, I will not show you those users more because that will show you what farm it is. I'm not too keen on showing you real people's names, but we can show you the scouts. Here are a list of the scouts that are registered scouting on this. And you have a settings page here where you see the users and you see your subscriptions. I just want to one detail that might be useful, particularly considering that many of you are, as far as I understand, many of you are in fact consultants and may want to use a tool like this for yourselves, where you may have a scouting device, you may go out, visit a client, record some observations, and then move on to another farm. So it's possible here to register a number of farms and then have what we call a common account, so that you register your device, pay for one device, and then you establish farms for each of your clients. And then you can share each farm with one client. So the farms that your clients will only see the farms that you have given them access to. You may also have them, they may be doing scouting, and you may be advising them based on information that you see in the scouting template. So the idea is we know several consultants that work with our platform. The farms do the scouting. They have scouts walking around the fields, recording data, and the consultant logs into the maps, looks at the maps, and based on their observations there, will make recommendations. Now, let's see. If I'm missing any details. I have one more thing I want to show you, but I think before I do that, let me open up for questions. Could we Ricky, are you there? Are you facilitating questions or?
Thanks, Mikhail. So I'm trying to pick questions from the audience, but as we wait for those, I've got a few that I just want to run by you. So
Yeah.
let me just walk through them.
Yes. Go ahead.
Okay.
Go ahead. Shoot.
So great. So thanks, Mikhail, for the presentation so far. And I think they're just, maybe let me just read out all the questions that I've picked up from the point we started your presentation to date. So one of them, I think when you are sharing on the graphs or the presentation of the data, there was a question about baselines and the opportunity or the ability to use this particular approach to plot scouting-based occurrences against baselines and baselines that are informed by seasonal occurrence and of course the fluctuations throughout the season for any given pest, so that based on what is plotted at any one point in time, there's also that pictorial kind of, overview that gives one an indication that, you know what, based on the baselines for this particular pest at any one point in the year, this is how you're doing, so that was one. And then there's another one, I think, when you were showing the operations and getting to the farm level, the question is on, are you able to precisely via the app pick out the location via GPRS, coordinates, and also the size of the farm, and can that also be done in terms of a grid all the way down to say individual blocks? And there's another one about the devices. You mentioned the scouting device. So is this any device, or is it a special phone, and what are the minimum specs? Then lastly, I think what you were describing right at the end, how can this application support what we call in Kenya telephone farming? So as you rightly said, you may have a consultant working with a farmer who's got their own staff, and the consultant is basically just providing advisory input based on the data and what is generated. So how does this application and approach support telephone farming? So those are a couple of questions so far. I'm also going to look out for a few others, and probably we could start with those ones and then move on.
Right. I think the first one was about the trend graphs, and if I understood correctly, it was about whether you could use it to help spot seasonal trends. Is that right? Or
yeah, so basically, I think in terms of layered data, is that option available, so that what are typically baselines or trends across seasonal patterns? Is that all? Is it possible to have that at the back, in addition to the real-time data, so that one can assess current status versus what may be historical or typical for a given area? Yeah.
right. At this point, it doesn't have any trends from other farms. If you're talking about benchmarks to other farms, or are you talking about climate data, or simply what the same farm did the last season, could be another criteria. There are many benchmarks that people use in the industry. But at the moment, Spot Ag doesn't support any of these. I'm sure it'll keep improving in the future. But basically it's, you know, you can compare your own fields, for example, different fields, but there's no baseline or yeah, benchmark.
So what you're saying is that the trend analysis is localized to the field based on historical data.
Yes.
Okay. Yes. All right. Okay.
It's actual observations. Yeah.
Okay. All right.
Yeah. And the next question.
So the second question was in terms of the precision when you're like mapping, because you showed us when you're logging onto the signing into the application, and how precise does it go in terms of, you know, like I can pick out my farm, can I get the individual blocks, you know, and that kind of data?
As you know, you'll see here as we're zooming in, you can almost see individual trees here, right? That does depend on the quality of satellite imagery in your area. The precision with which the scouting data is recorded really depends on the GPS on your device. In this system, we have no correction. Most devices these days, and someone asked the question about what devices are we talking about? We're basically talking about any Android phone. And almost the vast majority of Android phones today would be good enough for this. Occasionally, there's a phone, a brand out there that may not have good enough GPS. When we started many years ago, back in 2005, GPS was not very precise. It could be 20, 30 meters away from the actual point. But nowadays, most phones will give you 2 to 3 meters. If you've held the phone clearly visible to the sky, it'll be a bit lower if you keep it in your pocket. But basically, you know, there's fairly good precision. And that's what it depends on, the GPS on the phone. In terms of, you know, I heard something about a grid. We don't actually have a grid in this. The precision, of course, also depends on how frequently you scout or how many scouting points you do. We are used to working in roses where you have a lot of people, you can put a lot of resources in and you can scout very, very intensively. So people will go down every second row of bed of roses. But once you start moving to things like avocado and other field crops, you obviously can't do that sort of intensity of scouting. And you need a system that's more flexible. Some people will want to scout a lot, very intensively, and others will just want to take a few samples in each field. You can draw your fields any size you want. There is a part here where you can draw fields. You can zoom in. Let me just zoom in and quickly draw this lake. I'll delete it afterwards. You draw a field like this, basically. Now, I guess this would be if you're fish farming, or maybe hippo farming. So you can draw this. And you can edit it afterwards. If you weren't quite happy with what you did the first time around, go in and adjust it afterwards. When you save the field, you can give it a name. You can select the crop and the planting time. You don't have to give a harvest time. In this case, I'm not going to save the field. I'm going to delete it now. But that's how easy it is to put in a new field, especially if you can see the area on your satellite imagery. If you don't have good satellite imagery, the app has the ability for you to walk around the field and mark it as you're walking around the field. The app also has the possibility of taking pictures and displaying those in the web. Well, when I say it has that ability, by next week it will have that ability. It doesn't have it today. So we keep developing new aspects. The thing with photography is in testing now, but will be released next week. I've just been looking at it in testing, and it's working very well. So that's a new feature next week. I'm just trying to remember what the next question was. Ricky, you one I haven't answered?
Yeah, I think you've spoken at least to the specs for the phone, and there was a question about the use with telephone farming. I think, and that as a phenomenon that is common here in Kenya.
Telephone farming. Yes, and I think it's this is where it could really come in very well. I'm particularly thinking of Nairobi farmers who have a plot up country and someone else is actually managing it, but they do want to keep an eye on it. This is a great opportunity for that. And in terms of being a consultant and using it to keep an eye on what your clients are doing, I think there are two different ways of approaching it. One is that you set up a separate farm, a separate account, so to speak, for each client, and that the client handles it. The client handles payments to the system. The client shares a view with you so that you become a guest on their farm, and are able to view what they're doing. The other approach, and I think I personally, as a consultant, I would take that approach, is that you establish the farm for the client, you invite the client to use it, you help them set up the scouting and train, maybe help train their scout, and then you invite the client as a guest to the farm. So they don't have to manage anything. They just have to see the results that come out. So they'll be able to see the farms. They'll be able to see all the maps. They'll be able to see the charts, the tables, and all the other things. Sorry, I just have to do something with my screen here, or it'll go off. I can see. Yep. Just yes. That way, I think, if a parallel that I'd like to bring up is accountants. Now, we have companies in 4 different countries, and some of our accountants have their own accounting system. And one of our accountants, the one in the UK, we have our accountants a system that our accountant works with. So in the countries where our accountants have their own accounting system, they charge us for the accounting. But here in the UK, we pay directly for the accounting system, and our accountant uses that system. So those are 2 different models that I would imagine that someone working as a consultant would use. You charge for your consulting services, and one of the things that you have as a cost in relation to that is the cost of the platform here. I can just quickly show how that works. The system charges for two things. One is per scouting device. So for each scout you have, there is either a monthly or an annual fee that you pay for that. So that is based on how many scouts you need. You'll pay a fee that gives you all the access for as many users as you want on the platform. So you can have any number of consultants, any number of people on this farm seeing the results, but you pay for each scout. There is also another thing that we have, which is satellite indices. You can get satellites pass every 5 to 6 days over Kenya, and you can get natural vegetation indices. You can get other, so satellite indices here: normalized vegetation index, red edge chlorophyll index, a number of different indices. The big unhelpful thing about these is that they only work on cloud-free days. So in fact, in many growing regions, they're not all that useful, because during the growing season, you will have clouds. Whereas in desert areas, for example, where you grow under irrigation, you would have a lot more use for these satellite indexes. Yeah, I hope that was clear.
Yes, and I think just on the same as you're elaborating on the charging models, apart from, I think in summary you're saying it's pay per use. Is if I'm getting you correctly?
Pay per scout. Yeah.
Pay per scout.
Yeah.
And the charging is not pegged to the area scouted. It's really to the number of scouts.
Yes, the number of devices that you use for scouting. So that means if you have, one of the reasons we're not going with area is because let's say, if you're growing tomatoes, you may want to scout much more intensively than if you have avocados. If you're growing avocados, you're not going to pay the same price per hectare that someone growing tomatoes is willing to pay, because avocados are simply not as intensive a crop as tomatoes. Or you may be growing sisal, which is even less intensive. So therefore, we decided to make it per scout. And you can decide whether you want to scout very intensively or not.
Okay, I think we're good until there. I haven't received any additional questions. Do you want to proceed? Yeah.
I have one more thing that I'd like to show. I'll just need to. So, one of the things we've been working on, our clients have been telling us that they're very pleased to know where their pests and diseases are. But what they would really like to know is where these guys are, the guys doing the spraying, and what they're doing, and where they're spraying, and how well they're spraying. So what you will notice is that there's a little device on this guy's back. This is a portable flow sensor. It measures flow, and it has a GPS in it, so it maps that flow. And that enables you to keep track of what is being done in the field. I'll just show an example here. Here is an example. Can you see my screen? A map of lines up and down, different greenhouses. So this is an example of There are 8 people spraying here. They're spraying in different teams. Here you have a team of 2 people. Well, there's a third person there for part of the day. Here you'll have 3 people spraying the different colors. You also have the size of the dots depends on how much they've sprayed. So here you have the possibility, you click on this and you can actually see what they've sprayed in this house. You can see what they planned to spray, right? So you're seeing that this guy was spraying 3.6 liters per minute. You can see where he walked. You can see whether he did enough beds. You can see that there's a part of the house here, this house, that wasn't sprayed. You can compare that with the program. In this case, I know that the program said that they shouldn't spray that part of the house. You can also spot things like over here. There were actually 2 sprayings in a day. Two different teams both entered this house and sprayed this house on the same day. Now that's not supposed to happen. That's a mistake. So this is new technology that we've developed. We're almost ready to release it. We've started working with a factory. We just need to produce the devices. And we will be launching this in Kenya later this year. We look forward to maybe working with some of you on this. I'm hoping that this gives the opportunity also for a new type of service beyond the uses that farms who have people spraying all the time. And they've already told us they need this. We've talked to lots of our clients about this. They are all very excited, looking forward to the technology. But another type of service that I could imagine is there are lots of growers who maybe don't spray very often. In fact, maybe don't even know very much about spraying, but they do need someone to come in and help them spray once in a while. And they hire people in. But I do know of some areas where people do work as teams of sprayers that come in, they'll spray one farm, and then they'll move on to the next farm where they'll be hired to spray there too. I'm sure that if I hired someone in to spray, I would really be wondering how good a job they did, particularly if they're not my staff. A bunch of unruly young men running around, spraying a field. It's really difficult to keep an eye on how well they did this. So I could imagine someone offering a service where they're spraying. Maybe they even have scouting and spraying as part of their service. So they send out scouts to different farms, and then they send out sprayers. So the scouts will be using the app to scout, and the sprayers will be using the tracking system to show to their clients that they did in fact spray. And this is where they sprayed, and this is how much they sprayed. And thereby be able to prove that they did a good job. Yeah, that is this new technology that we're looking forward to releasing later this year.
Great, thank you, Mikel. I just want to follow up on that last point you mentioned, and with the concept of spray service providers, what you call contract sprayers, who come into an area and make applications, and they're paid on the basis of what they applied, and the ability, I think, using the device you've just mentioned to then actually see the quality of work that was done. How does that work out from a costing perspective? That's one question. And then as a second follow-up, well, separate question, what are the potential uses of this technology and approach for area-wide IPM programs and area-wide programs, for example, looking at the fruit fly menace and the fact that these insects are so mobile, and when you're looking at control programs, you can't quite just work it from an individual farm. You have to kind of use area-wide control approaches. So, do you have any insights, any lessons or case studies that you may perhaps want to share about area-wide control? So those are the two questions we have as a follow-up.
Well, I don't have any experience with area-wide control, and considering that we don't have the device out on anything but a trial basis yet, since we have not yet begun manufacturing. All the units we have at the moment are prototypes. I can't really say, I can't talk of any experiences, but I can hypothesize. I would imagine that if you're sending, I don't know how these area-wide programs work. Are you talking about where somebody actually comes from a centralized program trying to spray in a larger area? Or are you talking about where each individual farmer does their spraying in these area-wide programs?
So actually what we're looking at, I think, just to expand on that question, for pest control programs that rely on a coordinated approach within a geographical area, to effectively manage the pest. Are there any examples where this approach of use of spatial data has been implemented, and how would that look like? I think it's just a learning opportunity, because we've appreciated this from the localized farm level, but when you're now trying to think, well, how would this work within, say, a county, where there's a program that is like, okay, we are running this program for fruit fly control within the county. So how now do we use this? Is it that the county is taken like the one big block, and then maybe divisions or smaller areas in the county are treated as specific areas? Just wondering in that sense, how would it work? Yeah.
Well, I think we have had some discussions in Ecuador about trying to use it for an area-wide program. There's just been a change of government, so discussions have stalled. But basically the idea, you could look at making a county or some smaller unit, different units as either drawing them as fields. The system allows you to have nested units, in the sense that you can draw a field within a field. So for example, if your county is your big field and you have subunits within that, you can draw those within that same field, and it'll give you the data. It'll calculate the data per each field that you have. You just need to name them so that you get a nice hierarchy in your tables. But you can have that sort of subdivision. We have previously worked with a scouting system that required very, very intense scouting, and because we were interpolating between points and we needed lots of data. So this system is flexible enough, the spot.ag is flexible enough to be able to be used for something like area-wide programs. You zoom out and you just draw much bigger fields. So we could, I don't have an example of a county, but if you imagine, okay, well, there are marked in there. And then you could, so this says this field, okay, at the moment, there's a restriction of 2,000 hectares for this field. We can change that. If you're interested in what this restriction is, really a restriction is that we can't do the satellite imagery for that bigger field. So we can enable it for the scouting. But yeah, it could work for area-wide programs. What was your other? A question
I think,
on the pricing of these devices. Pricing hasn't yet been determined, but it will be determined. People will need to buy the device, and then there will be a subscription for use. This will be a monthly subscription. So it's not likely to be for the small farmer who sprays once a week, because they're not likely to make enough use of the device to justify it. But I can easily see it being used in, even things like malaria residual spraying programs, or other programs where you really want to keep track of, especially if you're sending people out all sorts of places where you really want to have a check on whether they've actually been there or not. That they haven't been down to the nearest lake and poured the chemicals into the lake, but that they've actually been around spraying the places they need to spray.
all right. I think that's quite clear in terms of the elaboration. So I think going back to the point on the area-wide controls, what that sounds like, and as you've said, the adjustment can be done from 2,000 hectares. So basically what I'm hearing is if say a county was rolling out a focus control program for one or two or several pests, then it will be a factor of how many scouts are deployed across the county, and then the very specific locations that they are then scouting within. So, I'm bringing this down so that even when it comes down to, say, a location, the scout would probably then, as a lowest unit, probably have to look at an individual farm, and that would be the equivalent of a block. So each block scouted, so to speak, would be a whole farm unit, and then the aggregation of those blocks would add up, and give you the whole spectrum for the county. So I think that is clear. So there's one other question on the Q&A, and this is: does the technology have capabilities of supporting prediction of pest occurrence? I think this is related to what we discussed earlier on trend analysis, but perhaps, Mikhail, you want to, maybe there's a different or additional input you want to make on that. So that's a question: does the technology have capabilities of supporting prediction of pest occurrence?
No, we don't have that at the moment. We would require a lot more data to be able to do that. At the moment, the system is fairly new. It is something that we would be able to work with once we have several years data over a larger area on specific crops and specific pests. We have no immediate plans to do that.
Okay, and as a follow-up to that question that the attendee has asked, we now talk of data and data integration, so where in some areas, say, data has been collected over time, we may not have certainty over the process that has been used, but there is, let's say, generally some fairly accurate data, historical, most probably of a wide location in terms of patterns or trends for a specific pest or disease or other such issue, is there an opportunity to then say create overlays by introducing that data into, like your dashboard, where your real-time scouting is then also overlaid with this? And how would that work?
We at the moment we don't have any of those capabilities. That's certainly good suggestions. We have looked at possibilities for that sort of thing, but we don't have those capabilities at the moment. They're interesting options. Yeah.
Okay. I think also to the other participants who are on the Zoom platform, because I've predominantly been raising questions that have come through from outside of the Zoom platform. But for those who are still here with us as we are drawing to the end, if you have any questions, please, you could also maybe raise a hand, or type it on the Q&A stroke comment box. So we've already answered one question, but I think the presentation from Mikel has been very clear in terms of the capacity and the capability of using technology. So I think we've appreciated that in terms of, first of all, technology taking us from previous way of approaching pest control based on the economic threshold principles, and of course now going to what is a very precision type pest control opportunity, using data, and of course by getting that data, mapping it through scouting, and then also following up on interventions that are made. So I don't know if there are any other questions, but of course I'm going to introduce one more. And Mikel, that's really about the other pest related operations on a farm or on an enterprise that do have implication for pest disease levels. So we're talking about nutrition. We're talking about, say, aspects such as harvesting that may take place in a neighboring farm, and by virtue of harvesting or crop removal, then you get pest migration. How is that factored? Is that just by virtue of the kind of templates or scouting templates that are used, or is that case by case? Anything you want to say about that?
But at the moment, we really haven't addressed that much. There are a few things like we include, we're in one template, we've included, growth stage of the plant. But otherwise, we haven't included much of these things. We've very much designed this system to solve the issue of displaying large amounts of constantly changing pest and disease data on a map that's useful to the grower. Pests and diseases are probably what changes most on a farm, more than anything else, and keeping track of them is a major issue. The number of data points that you need are a lot, and many of the systems that we've seen out there are really only suitable for, showing hundreds of points maybe. But the fact is that you very easily get to be showing thousands of points, even tens of thousands of points, and being able to handle these well is in a very simple way is what has been our main target. And of course, eventually it'll grow to other things too. But that's been really the critical aim of this app.
Great, Mikel, thanks. I think that's a really strong takeaway. I mean, it's about simplifying what is typically a complex activity, and through that simplification, the opportunity to to achieve cost savings really does come up. And as we are closing, perhaps just to tell us in terms of next steps and how for the consultants who are following this, and those who will also follow the recording, how do we get in touch? How do we onboard? You know, how do we take this forward with Scarab Solutions?
Right. You've got a number of options. I'm sure you'll be sharing my email with the participants. At least you're welcome to do that. So they're welcome to contact me. It's also possible to contact Jeff Masharia at Scarab Solutions in Kenya, our lead, the regional director for Scarab in Kenya. And then there is another option. You know, young people today, they don't need so much help. You just log in and get started and look around. And maybe you'll be able to figure it all out by yourself. Some of the young people will be able to do that. But if you need any help, please contact us, and we'll be happy to jump online and support. And while we're at it, I would like to thank you, Ricky and Soka, for and Mercy for organizing this and our participation in this. We've been very happy to be able to present and hope that you all find it useful in one way or another.
Most definitely, Mikel. Thank you so much for your presentation and addressing those questions. So to Dr. Mikel from Scarab Solutions, a big thank you. I think that has been a very well elaborated presentation. We have a very good picture of how spatial data can assist in integrated pest management programs. And of course, for our listeners and you know, followers and viewers, we will be sharing the contacts for Scarab Solutions so that you can follow this app should you want to, you know, engage directly and see how this can be of use with supporting your target audiences. Mikel, thank you so much. I think it's really been a privilege to get this update and, you know, to get some of the sneak previews, so to speak, in terms of functionalities and capabilities. And we do look forward to hearing from the consultants who make use of the application, how it has helped them and assisted them in making their support services more effective or more efficient for their clients. And of course, we continue to wish Scarab well in its business. We appreciate the data and what you have shown us, even in terms of what has happened by way of the use of such technology for pest control in Kenya. We really do appreciate that and wish you well with your continued operations. So listeners and viewers, thank you so much for your participation. Thank you for the questions that have been raised. And we do hope that this segment has been instrumental or informative for you. And of course, we look forward to seeing you next week on the next topic for the SOCA Masterclass. So as we close, I do wish you all a good evening or good afternoon, wherever you are. Thank you so much for your time. Thanks, Mikel.
Thank you very much.
All right.
Bye.
Bye.